Hello students, welcome back. Let's get on with the proofs. In the previous video we talked about the proofs of these limits, and we're going to use these to prove the derivative formulae for sine and cosine. Okay, here we go. This is the derivative formula, or this is the proof of the derivative formula for the sine function. And let me see, let's copy and paste that. Oops. Obviously I wasn't able to copy and paste perfectly, so let's do this again. Okay, now we're ready. We're gonna be using these two formulae, and let's color code this one in red and this one in blue. And let's go to this proof. Derivative of the sine function, so let's put it into the Newton quotient for sine. Sine of x plus h over sine of x over h. This is nothing more than the Newton quotient. We went through that before. Next, let's decompose this sine of x plus h using the sum identity of sine function. That wasn't too bad. Okay, and then here's a little bit strange decomposition. We're going to take first and the third term together into one fraction, and then a second term for the second fraction. First term and a third term put together for this fraction, and then second term goes to the second fraction. Does it help? Yes, because first and the third, sine of x is common. So if I can factor it out, what do you have left? Cosine of h minus 1 over h. That's going to go to 0. How about the second fraction? We have sine of h over h. So this one goes to 1. In the end, what do we get? Sine of x times 0, so that part drops out, and cosine of x times 1, so that part stays. In the end, what do we get? Cosine of x. That's a derivative computation. Did I say derivative computation? Excuse me. Proof of the derivative rule. The proof of the derivative rule. How about the derivative rule for cosine function? Very similar. We put it into the same Newton quotient here. Cosine of x plus h minus cosine of x over h. Same, it's Newton quotient. That's the definition of the derivative. And then we decompose this cosine of x plus h using the sum identity for cosine. Cosine of x cosine of h minus sine of x sine of h. And then we do the same thing. The first term and the third term, we put them together to form one fraction. And the middle term, the second fraction. How does it help? Well, we can factor cosine of x out. And what do you get? Cosine of x out. And what do you get? Cosine of h minus 1 over h. That goes to 0. From the second fraction, we have sine of h over h, and that fraction goes to 1. In the end, what do we get? That part is 0, that part is 1, and cosine of x times 0 minus sine of x times 1. In the end, you get negative sine of x. So much for the proof. How about the other trigonometric functions? There are 4 formulae, and then they're just tedious. Here we go, the derivative of the tangent function. We have sine over cosine, So we use the quotient rule. Denominator squared and then u prime v minus uv prime. In the end, what do you have in the numerator? Cosine squared plus sine squared. It's 1, so we have 1 over cosine squared. We end up with secant squared. A little bit tedious computation, but everything's based upon the derivative formula for sine and cosine. How about the next one? Derivative of secant, which is derivative of 1 over cosine of x. And oh, here I use that chain rules to calculate this derivative. It works, but I didn't teach you the chain rule just yet, so I'd better use quotient rule here. So let me redo this. So the denominator squared, and then the derivative of numerator 0 times denominator minus 1 times derivative of denominator. So we have sine of x over cosine of x, and then you have cosine squared of x, so I need another cosine of x. That is secant of x times tangent of x. Next, the derivative of the cotangent function, again, is a quotient rule. We have cosine over sine, and then put it into the quotient rule, denominator squared, and then u prime v minus uv prime. What do you get in the end? Negative sine squared minus cosine squared. So it's negative 1, and thus we have negative cosecant squared. The final formula here, again, I use the chain rule here, so let's redo this using the quotient rule. Denominator squared, and then we have u prime v u and v prime. So what do you get? Negative cosine of x over sine of x times 1 over sine of x again. So what do you get? Negative cotangent of x times cosecant of x, or cosecant of x times cotangent of x, because multiplication is commutative. Either way it works out. That completes the proof of all these trigonometric functions.